recipe to perform some task. You do this first, then this, then this, then this. That's a procedure or an algorithm. Now, an algorithm is recursive if within the algorithm there is a call to itself. It recurs, it happens again. Okay? And context-free grammars have this element in them. They have this, they have a certain recursive nature, and that recursion that occurs within the grammars gives them, well, it's one of the reasons for their power. You can describe a greater range of languages than the regular languages. Now, context-free languages, they're the languages generated by these grammars, context-free grammars. They include the regular languages, but more. Okay, so in that sense, they're more powerful. They're capable of recognizing more languages than only the regular languages. Okay, so in that sense, more powerful. Okay, so it'll become clear a bit later what a context-free grammar, a CFG, is. So shortened to CFG. I'll use that abbreviation a lot. Okay? Now, these CFGs, context-free grammars, they were first used in a study of human languages. Now, the text doesn't mention it, but you may have heard of the famous, some would say infamous, Chomsky, person named Noam, N-O-A-M, Noam Chomsky. He's famous for two things, largely. One is, he's pretty well the guru of modern linguistics, the study of the structure of languages, human languages, spoken languages. And he's a very strong critic of particularly the US government in its abuse of its power, its enormous power. America is the dominant nation on the planet in the 20th century. And there have been many examples where that power has been abused and to the detriment of the rest of the world and America. And Chomsky is a sharp, very sharp critic of this abuse of power. So personally, I love Chomsky. For me, he's the sort of role model. I mean, he's a bit older. Well, actually, he's quite a bit older. He's more like 20 years older than I am. And I'm getting old. I'm mid-60s, but he must be 80s, and he's visibly aging now. So I have, many of his videos and talks, voice, listening to him criticizing the abuses of the US government. Anyway, so he's the pioneer of linguistics, and he was using these CFGs, context-free grammars, to analyze the structure of human languages. Okay, so that's how it started. And then the early pioneers in compiler theory. Remember a compiler? Talked about that a bit earlier. What is a compiler? It's a translation program, and it translates high-level English-like strings, phrases, into very low-level machine code. In other words, just basically bit strings, noughts and ones. That's what the machine, the computer, understands. Right? So it's much easier for human programmers to write in high-level, human-level code, with English-like words, and then have a machine translate that automatically into machine code, zeros and ones, very low level. Because before there were compilers, these translation programs, programming a computer directly in zeros and ones was painful, tedious, and extremely error-prone. It was easy to make mistakes, and so you'd waste a huge amount of time debugging the program. Just for fun, I'll tell you a little story about debug. Where'd that come from? What has debugging got to do with... What is a bug, in other words an insect, got to do with removing the errors, the logical errors or typos in a computer program? Well, story goes back to one of the very first programmable electronic computers. America's was called the ENIAC, E-N-I-A-C. What's that? Electronic numerical automatic. I don't know. Anyway, ENIAC. Well, in the summer, this machine had tens of thousands of valves, electronic valves. So the large room that contained the machine got very hot, and the programmers are often women, young women, and the men are off to wars. Is that right? That can't be right, because I don't think it even finished. The construction was finished until the end of the war. Anyway, a lot of the programmers were women, and it gets so hot that that's stripped down to virtually bra and panties. And one time there was a persistent bug, and it was everyone were pulling their hair out, couldn't figure out. They tried everything and everything they could think of it didn't work. So then they were starting to think, well, maybe it's not a software problem. Maybe it's not the programming that's wrong. Maybe there's something actually wrong with the hardware. And so eventually somebody crawled into the guts inside the machine and found an insect that had caused a short circuit. It had touched two electrical wires or something and fried, the voltage difference. It had fried, and the insect was just stuck there, but the insect itself was conducting current. So in other words, current was flowing through the insect, causing a short circuit of the circuitry, and hence the computer, the hardware, was malfunctioning. And so they got rid of this bug. They threw out this insect, so they debugged. Got rid of the insect from the machine, from the hardware. And so ever since, to debug means just get rid of the error with a hardware software from your computing. So hence to debug. All right. Okay. Chomsky. Now, the early pioneers of compilers were, some of them knew about the efforts of Chomsky applying context-free grammars to and grammars to the analysis of human languages, and then when your compilers, these translation programs, were created, they applied similar techniques. Okay? So, like if you look at the nature of human sentences, they contain like nouns and verbs and prepositions and noun phrases and verb phrases and prepositional phrases and so on. And within these phrases can be, like a noun phrase may contain a verb phrase, or a verb phrase may contain a noun phrase, and so on. So in other words, you're getting, in a natural way, recursion. If you define a noun phrase, the noun phrase may contain, as part of its definition, a verb phrase. And the verb phrase, in turn, as part of its definition, may contain a noun phrase as a component, right? So you get this sort of recursion. And these context-free languages allow that kind of recursion in the way they're built, in the way they're constructed. So context-free grammars, CFGs, were very useful for compiler writers. It allowed them to write out a grammar, CFG, for the compiler, that the compiler could then obey, that would actually use that grammar. Okay, so the idea of CFGs coming from the analysis of human languages to computer languages, right? Quite a close analogy, right? That's what's being said here. So if you really want to know the detail of a computer language's syntax, in other words, what symbols are allowed, that kind of thing, the letters and symbols, and then one effective way to do that is to look at the program language's grammar. You know, it's CFG. Okay. So a designer of a compiler can actually begin with the grammar, right, and then write the compiler based on the grammar. Well, I'll just go straight on with the next session.